Hello dear students, welcome to the physics class. In previous video we learned about the total internal reflection and also we learned the conditions for a total internal reflection. And we also discussed how the critical angle and refractive index of the medium interrelated to each other. Now in today's class we are going to discuss the applications of total internal reflection. In daily to daily life, we will observe there are so many phenomena because of total internal reflection. Now we will discuss some of the applications due to the total internal reflection. The first one is brilliance of a diamond. Brilliance of diamond. Brilliance of diamond takes place due to the total internal reflection. Actually, the diamond has the greater value of a refractive index. The refractive index of diamond is 2.4. This is the refractive index of a diamond with respect to air. And we know that if the refractive index value is more, then the critical angle value is less. So that the critical angle for diamond with respect to air is critical angle, that is C is equal to 25 degree, that is nearly equal to 25 degree. So the diamond has the higher value of a refractive index, that is the 2.4, and a lower value of a critical angle, that is a 25 degree. When the ray of light passing through the properly cut diamond, then it will undergo the total internal reflection. Now we will see how the total internal reflection takes place in the case of a diamond. See, now I am taking on a diamond. This is the properly cut diamond. Assume that this is the properly cut diamond. Okay. Now I am going to incident ray of light. Now I am going to incident a ray of light like this. When it enters to the diamond, see here, I am going to incident a ray of light inside the diamond, then it will hit to the surface of the diamond. It will hit to the surface of the diamond. Then if the angle of incidence is greater than that of a critical angle, suppose that if I draw on a normal here, then if the angle of incidence is greater than that of a critical angle, then incident light will undergo the total internal reflection. So that it will undergo the total internal reflection like this. Again, if the angle of incidence, now this is the incident ray of light for this surface, it hits to this surface. Suppose that if again I draw the normal, if the angle of incidence again greater than the critical angle, that means angle of incidence is greater than the 25 degree, then again it will undergo the total internal reflection like this, and it will come out from the another face of the diamond. But properly cut diamond there are so many surfaces inside it, right? Properly cut diamond there are so many surfaces. So because of that, the incident ray of light undergoes the multiple total internal reflection. Okay, because of there are so many surfaces inside the diamond, so it will incident ray undergo the multiple or series of total internal reflection inside the diamond, so that diamond will get sparkle. So that is the first application of a total internal reflection. The second application of total internal reflection is mirage. Mirage. So mirage is an optical illusion. It is an optical illusion. Optical illusion due to total internal reflection, reflection reflection at air layers of different density. So mirage is the optical illusion due to the total internal reflection at air layers of different density. Especially this mirage occurs due to the total internal reflection, and we will observe this total internal reflection especially in the hot summer days. We will observe this in hot summer days. Now we will see how the mirage takes place. First I am going to consider one taller object here. This is a tree. I am considering here tree. And this is the ground. And we know that in hot summer days, the air layer which is near the ground is hotter compared to the air layers above the ground. So that air layers near the ground is less dense, and it has the less refractive index. The air layer near the ground, that is a hotter layer, and this is the hotter layer of air, and here density is less, and its refractive index also less. Because of that, the air layers near to the ground behaves as a rarer medium. Here the layers behaves as a rarer medium, and above this ground level, the air layers are much dense, because the air layers above the ground are cooler compared to the air layer near to the ground. So that it is much dense. That means the density of air layer above the ground is more, and refractive index value also more. Okay. That's why the air layer above this ground behaves as a denser medium. Okay. Now we'll see how the total internal reflection takes place. Okay. See here, I am considering here there are different layers of air. And here the light which is coming out from the sun, and it will hits to the object. Here object is a tree. When it hits to the object, it will reflect back like this, and it will enter to the air layer which is above the ground. We know that the air layer which is above the ground is much denser. That means it behaves as a denser medium, and it try to enter to the rarer medium. That means when the light enters to the rarer medium from a denser medium, then it will undergo the refraction, and it will bend away from the normal. Suppose that if I draw normal here, then this light ray will bend away from the normal like this. Again, it will undergo the refraction when it enters to the another layer of air, and this is the normal. Again, it will undergo the refraction and bends away from the normal. Suppose that if the angle of incidence is greater than the critical angle, at particular angle of incidence, the angle of incidence is greater than critical angle. Suppose that the angle of incidence is greater than critical angle, then the incident ray totally reflects back to the same medium. Okay. Then suppose that if a person observing this is a person who is observing this object, then he assumes that the light ray which is coming from the pool of water which is near to this object, that means here it will undergo the total internal reflection, and this ray of light which is enters to this person, and he will feel that this object which is reflecting from pool by pool which is reflecting by the pool of water near to this object. That means he assumed that there is a pool which is near to this object, and that image he is getting. He assumes that image he is getting from this pool. Okay, and he will observe the inverted image of this object, and this illusion, this optical illusion is called as a mirage. Especially this one we will observe in the case of hot summer days. That is the another application of total internal reflection. The third application of total internal reflection is optical fiber. Optical fiber. Now let us see, what do you mean by optical fiber? Optical fiber is the transparent fiber. It is the transparent fiber of glass or plastic. It is the transparent fiber of a glass or plastic which can transmit light, along any desired path. So that is called as an optical fiber. Optical fiber, actually it is the transparent fiber, and it is generally made up of plastic or glass, and it is mainly used to transmit the light from one place to another place. Actually here we are transferring the digital informations in the form of light from one place to another place. So that is the optical fiber. Now let us see what actually the optical fiber consists of. Mainly there are three parts in an optical fiber. There are three parts of optical fiber. They are nothing but first one is the core, and another one is the cladding, and the third part of the optical fiber is protective cover. Now let us see how to draw the optical fiber. See, this is the diagram of an optical fiber. So this is the diagram of an optical fiber. Optical fiber consists of, there are three parts. So this part is called as a core. This is the core, and outside this part is called as cladding, and this both core and cladding covered by the one cover, that is the protective cover. Why we are using protective cover here? Because core and cladding is the more delicate parts, and it has a very less diameter, that is in microns. So that to protect core and cladding from the moisture and all, we are using one cover. That cover is called as a protective cover. And the radius of core is 62.5 microns. This is the radius of core. And the radius of cladding is nearly 125 microns. So that much of a small value of radius both the core and cladding has. And 1 micron means, generally 1 micron is equal to 10 to the power minus 6 meter. Okay. So this is the diagrammatically we are representing the optical fiber. Now we will see how the total internal reflection takes place in the case of optical fiber. See, here I am drawing the inner part of this optical fiber here. This is the optical fiber. Only the two parts I am showing here. This part is cladding. This is the cladding. This also cladding. And the inner part is the core. Here, core is much denser than the cladding. That means the core has a more refractive index than the cladding. Understood? So now I am incidenting light from one end of this optical fiber. I am incidenting light from one end of this optical fiber. When it enters to the optical fiber, then it will undergo refraction. It will undergo refraction. It will bend a little and it will undergo the refraction of light like this. And when it undergoes the refraction of light and when it enters to the core, it will meet the interface between the core and cladding. And we know that core is much denser than the cladding. So that core acts as a denser medium and cladding acts as a rarer medium. If the angle of incidence is greater than that of the critical angle, suppose that this is a normal. Now, if the angle of incidence is greater than the critical angle, it will undergo the total internal reflection. That means it will reflect back like this, and when it reflect back like this, and it will hit to the another surface of the another interface between the core and cladding. Again, if the angle of incidence is greater than the critical angle, then again it will undergo the reflection. Like this, it will undergo the total internal reflection, and finally it will come out from the another end of the optical fiber. Here, cladding actually acts as a reflecting surface, and the cladding has a less refractive index compared to the core, and it is less denser compared to the core also. Understood? So here we can transfer the digital informations from one place to another place in the form of light. That is about the optical fiber. Now let us see what are the applications of optical fiber. Applications. Commonly, we are using the optical fibers in the case of a communication field. In communication field. That means telecommunication field. We are using this optical fibers to transmit the digital informations. That is one of the application of optical fiber. And another application of optical fiber is to examine the inner parts of human body. Especially in the medical field also, we are using the optical fibers also. In medical field, to examine the inner parts of the human body, we are using the optical fiber. And this process normally called as, in general it is called as endoscope. These are the main two applications of optical fiber, and these are 3R. That means first one is the brilliance of diamond, second one is the mirage, and the third one is the optical fiber. These three are some of the main applications of total internal reflection. Dear students, we already studied the refraction of light at a plane surface. Now we will discuss the refraction of light at a spherical surface. Okay. So we know that refraction of light is nothing but a bending of light when it travels from one medium to another medium. Now we'll see how the refraction of light takes place in the case of a spherical surface. Before that, we'll discuss what do you mean by spherical surface. Spherical surface. Spherical surface is the part of a solid sphere. So if you consider one is solid, then spherical surface is the part of this solid sphere. Okay, and in the case of a plane surface, you have studied the laws of refraction, and in this case also, in the case of a spherical surface also, laws of refraction is applicable. Okay, here also laws of refraction is holds good. Understood? And in spherical surface, there are two types of spherical surfaces. The first one is the convex spherical surface. Convex spherical surface. And the second one is the concave spherical surface. Concave spherical surface. Now let us draw the convex spherical surface. I am going to draw the convex spherical surface. This is the way of drawing the convex spherical surface. Here I am considering there are two mediums. This is the rarer medium and this is the denser medium. And in this case, which is the refracting surface. So here the refracting surface is convex towards the rarer medium. Okay, refracting surface. Convex towards the rarer medium. That means if you observe, this is an convex, right? So convex surface is a refracting surface, and that convex surface is towards the rarer medium. That is called as a convex spherical surface. So refracting surface is convex towards the rarer medium. And how to draw the concave spherical surface? See, this is the way of representing the concave spherical surface. And this one is the I am taking as a rarer medium, and this one is the denser medium. In this case, refracting surface is concave towards the rarer medium. Okay, refracting surface is concave towards the rarer medium. Refracting surface is, see here, concave towards the rarer medium. So this is the way of representing the convex spherical surface and concave spherical surface. Now let us discuss some of the important terms which is related to the spherical surface. The first term is aperture. Here the terms which I am going to write is same for both the convex spherical surface and the concave spherical surface. Here first term is the aperture. Then what do you mean by aperture? Aperture is nothing but the area of spherical surface, available for refraction is called as aperture of the spherical surface. That means, see here, it is an convex spherical surface. How much area available for the refraction of light? Then that much of area is called as a aperture of that spherical surface. See here, this much of area it consists for the refraction of light. So that is the aperture of that spherical surface. This is the first term, and the another term which is we are commonly using in this spherical surface is the pole. Pole of the spherical surface. Pole is nothing but it is the midpoint of the spherical surface. Midpoint of spherical surface. See here, in this case, this is an refracting surface of this spherical surface. Here it has one midpoint. Okay, it has one midpoint. Assume that this is an midpoint. Then this midpoint of this spherical surface is called as a pole. This is now pole. Okay, that is the another term. And the third one is center of curvature. Center of curvature. Center of curvature. Then what do you mean by center of curvature? Center of curvature is nothing but it is the center of sphere. Center of a sphere of which the given spherical surface forms a part. Then it is called as a center of curvature of the spherical surface. See here, we know that spherical surface is nothing but it is a part of the sphere. If we consider one sphere, then it has one center. If I consider this is an part of the sphere, then it has one center somewhere here. Then that one is called as a center of curvature of that spherical surface. This is the center of curvature. Next term is principal axis. Principal axis. We already know that. We already studied this term in the case of mirrors also. Here also the same definition. Principal axis is nothing but it is the line. It is the line which is passing through the line which is passing through the pole and center of curvature of the spherical surface. That is called as a principal axis. So principal axis is nothing but it is a line. So it is just a line, and that line which is passing through the both pole and center of curvature of the spherical surface. Then it is called as a principal axis. And the next term is nothing but radius of curvature. Radius of curvature. Radius of curvature is nothing but it is the radius of sphere. Radius of a sphere in which it is the radius of a sphere of it is the radius of a sphere of which the spherical surface forms a part. Spherical surface forms a part. Then it is called as the radius of curvature of a spherical surface. It is the radius of sphere of which the spherical surface forms a part. That means if we consider one sphere, it has one radius, right? Radius is nothing but it is the distance from center to the surface of the any point on the surface of the sphere. Suppose that you can call it is the distance from a pole to the center of curvature of the spherical surface. Then we can call it as a radius of a curvature. So that is the radius of curvature. Simply we can call it is the distance from pole to the center of curvature of the spherical surface. That is the another term of the spherical surface. Now we will discuss some more terms related to the spherical surface. That is, next one is the real object. Real object. What do you mean by real object? Real object is nothing but when diverging ray of light, incident on a refracting spherical surface, if the ray drawn backwards meet, then meet at some point, then that point is called as a real object. See here, this is important in the case of spherical surface. When diverging ray of light incident on a refracting spherical surface, if the ray drawn backwards meet at a point, then that point is called as a real object. See here, suppose that diverging ray of light. What do you mean by diverging ray of light? If I consider one light source, assume that this is a light source, okay, I am taking it as O. The light rays which is coming out from this light source, okay, that means it is diverging out from this light source. So if the diverging ray of light incident on this surface, I am going to incident diverging ray of light. See here, I am incidenting diverging ray of light like this. This is called as a diverging ray of light. Then if I draw this ray of light like this backward, then it will meet some point on this principal axis here. Then that point is called as a real object. Okay, this is now real object. That means here I am going to incident a diverging ray of light. This is the diverging ray of light. And suppose that if I draw this incident ray of light backward, then it will meet some point on this principal axis. Then that point is called as a real object. And another term is virtual object. virtual object. Yes, what do you mean by virtual object? Virtual object is nothing but when converging ray of light, incident on a spherical refracting surface of the refracting spherical surface. If the ray drawn forward will meet a point, then that point is called as a virtual object. Then that point is called as a virtual object. Here we are going to incidence a converging ray of light. When we incidence a converging ray of light, if we draw the ray forward, then it will meet somewhere at a point. Then that point is called as a virtual object. Now see how to draw the virtual object in this case. See, first here in this case you should incident a converging ray of light. Then what do you mean by converging ray? Suppose that if you consider this object, this is just a object, now it is not a source. Now ray of light which is entering to this object like this, now it is entering, then it is called as a converging ray of light. So here we are going to incident a converging ray of light. So this is an converging ray of light like this. That means it try to meet somewhere at a point. These two light rays which is trying to meet somewhere at a point, then it is called as a converging ray of light. Suppose that if this two rays of light hits to this refracting surface, then suppose that if I draw this ray of light, forward, then these two rays of light meet at some point on this principal axis. That means here the point in which the two rays of light meet, then that point is called as a virtual object. This is now virtual object. Okay, that is about the real object and virtual object. Similarly, we will get the real image and virtual image. Now let us see what do we mean by real image and virtual image. The another term in which we are going to use in the case of a spherical surface is real image. Eighth one, real image. Then what do you mean by real image? Real image is nothing but if the rays after refraction at a spherical surface, converge to a point, then that point is considered as real image. Okay, so When I incident diverging ray of light to the spherical surface, I am going to incident diverging ray of light. See here, this is the diverging ray of light I am going to incident from the object. Okay. So here, when it hits to the spherical surface, it will undergo the refraction of light. It will undergo the refraction of light because the ray of light incidenting from one medium to another medium. This is an rarer medium, this is an denser medium. So that it will undergo the refraction of light. When it undergoes the refraction of light, it will bend and these two incident light rays are meet at some point after refraction. This is the point in which we are getting, and in this point both the incident rays are meeting after refraction. Then this image is called as a real image. This is an real image. That is the real image. And another term in which we are using here is virtual image. Virtual image. Then what is by virtual image? Virtual image is nothing but if the rays after refraction, if the rays after refraction at a spherical surface diverge, the point in which the rays drawn backward meet, then that point is called as considered as virtual image. So that is the definition of a virtual image. Now let us see what do you mean by virtual image. Here I am going to draw concave spherical surface. This is an concave spherical surface, and this is the principal axis of the concave spherical surface. Here I am going to incident ray of light. I am going to incident a ray of light. That is, I am here going to incident converging ray of light like this. These are the converging ray of light which is incidenting on the refracting surface. When it meets to the refracting surface, it will undergo the refraction because this one is the denser medium, this is the denser medium, and this one is the rarer medium. I am incidenting light from one medium to another medium. Then it will undergo the refraction like this. It will bend like this. Suppose that if I draw a ray of light backward, okay, if I draw this ray of light backward, it will meet some point on the principal axis. Similarly, if I draw this refracted ray of light backward, that one also meet on this principal axis. The point in which the refracted ray of light meet on the principal axis, that point is called as a virtual image. Now here you are getting the image, that is the virtual image. Understood? Because of extending this refracted ray backward, you are getting this point because of extending this both the refracted ray of light. That point is called as virtual image. That are the some important terms in which we are using in the case of spherical surface.